In this video, I'm going to show you how to solve my advanced GCSE Maths question, Help the Homeowner. So this is quite an interesting question because it uses a lot of different skills from GCSE Maths, like sequences and kind of solving simultaneous equations. So I'm going to start the video by just reading through the question. So this is an advanced GCSE Maths question called Help the Homeowner. A homeowner wants to make a decorative centerpiece for their home. The centerpiece will have several rows. The top will have one box, the second will have two boxes, and so forth. At either end of the rows, a decorative ornament will be placed. No ornaments will be placed on top of the centerpiece or on the bottom row. The diagram shows an arrangement with 5 rows. The homeowner does not know how many decorative ornaments they have, so they desire a formula for how many boxes they will need for any amount of decorative ornaments. Derive this formula. Okay, so the way I would start this question is first by drawing a table. So the table needs 6 columns. So 1, 2, 3, 4, 5, 6. And it needs 2 rows, 3 rows even. And the top row should be called rows. The second row should be called ornaments, or perhaps boxes, actually. Let's do boxes instead. And the last row we'll call ornaments. Ornaments. So what we're going to do is we're going to create several of these centerpieces with different amounts of rows. Now, if the centerpiece only had one row, we'd only have one box. But because the ornaments can't be on the bottom row, that means if the centerpiece only has one box, that means we don't have any ornaments. But if we have 2 rows, we'll have 3 boxes. The bottom row won't have any ornaments, but the top row will have 2 ornaments. So that means we have 2 in total. Now, if the centerpiece is 3 rows big, there will be 1, 2, 3, 4, 5, 6 boxes, and there will be 4 ornaments because the bottom row won't have any ornaments. Now, if there are 4 rows, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes, and there will be 6 ornaments. And if there are 5 rows, there will be 15 boxes, and there will be 8 ornaments. So now if you look carefully at the boxes and ornaments, what we're forming here is a sequence. So the boxes sequence is 1, 3, 6, 10, 15, and the ornament sequence is 0, 2, 4, 6, and 8. So let's start with the ornaments, and we're going to call ornaments X in this case. So we're going to let ornaments be equal to X, and we're going to say that the number of rows is equal to N. So what we're going to do is write the sequence down. So we have the first row, second row, third row, fourth row, fifth row, and the ornaments will be 0, 2, 4, 6, 8. So you can see that we have a linear sequence here because each time we move a term to the right, we're adding 2. So if we work out our nth term, it will be 2n minus 2 be our nth term, and we're going to say this is equal to x. So the number of ornaments, x, will be equal to 2 times the number of rows minus 2. Now we're going to do the same for the boxes. So we're going to say we're going to let the boxes be equal to y. So we have 1, 2, 3, 4, 5, and then it increases, the boxes increase 1, 3, 6, 10, and 15. And the common difference here changes as we increase the term. So you can see that each time we move a term to the right, our common difference increases by 1. And this is an example of a quadratic sequence. So the common difference increases by 1 each time. Now this is actually, quadratic sequences are the hardest level of GCSE problems. So they're classed as a grade 9. So to work out the nth term of a quadratic sequence, we halve this plus 1 here to make half. And this will be half n squared. We then make a new sequence by putting the number of rows into our half n squared. So the first term will be 1. So 2 squared is 4, times by half is 2. 3 squared is 9, times by half is 4.5, so this will be 9 over 2. 4 squared is 16, times by half is 8. And then 5 squared is 25, divided by 2 will be 25 over 2. Now the next thing we do is we subtract each of these terms from our quadratic sequence. So 1 minus 1 is 0, 3 minus 2 is 1, 6 minus 4.5 is 3 over 2, 10 minus 8 is 2, and 15 minus 12.5 is 2.5, which is 5 over 2. So now we have a linear sequence. Sorry, this should be a half, this one. So this one should be a half, because 1 squared is 1, times by half will be a half. And now we have a linear sequence, so each of the terms increases by half. So that means the nth term of this linear sequence is half n. So that means we need to add that to our quadratic term. So that's half n. And that means the number of boxes, y, is equal to half n squared plus a half n. So you can actually try enter some of these values of n, which remember is our number of rows, into the equation, and you should find that you get the correct number of boxes for that number of rows. Okay, so now we need our equation or formula in terms of the number of boxes and the number of decorative ornaments. So what we need to do is we need to solve both of these two equations simultaneously to get rid of the n. So the way we can do this is we rearrange our x formula. So n is equal to x plus 2 divided by 2, which is the same as a half of x plus 1. And then we need to enter this into our second equation. So y is equal to half and half x plus 1, x plus 1 squared, plus half x plus 1, and then we need to expand the brackets. So first we need to expand this quadratic, so we can do that using a table. half x, 1, 1. So half x times a half x is equal to x is equal to x squared over 4. Half x times 1 is x over 2. Half x times 1 again is x over 2. 1 times 1 is 1. So that means our expansion is equal to, so y is equal to a half times x squared over 4 plus x plus 1 plus a half x plus 1. Now if we expand the brackets again, we get y is equal to x squared over 8 plus x over 2 plus a half plus x over 4 plus a half. So y is then equal to x squared over 8 plus 3x over 4 plus 1. And this is our equation that we need. So if we put in our number of ornaments, say as being, say the last one, so x, so 8 squared will be over 8 plus 3 times 8 over 4 plus 1 is equal to y. So then y will be 64 over 8, which is 8. 3 times 8 is 24, divided by 4, which is 6, plus 1. So then that will be 15, which is the correct answer. So now you could use this formula here to work out the number of boxes required for any number of decorative ornaments, which will answer our question.